So this lecture is on the chemical sedimentary rocks. So separating the two types out, remember that chemical sedimentary rocks form from chemical sediment, and that is sediment that has been dissolved in water. So the minerals have been separated into ions and atoms that are floating around in the water. We can't see that sediment with our eye. You need a special kind of microscope, not just a regular microscope, in order to see atoms. They're very tiny. So before we get started, we've already talked about the detrital sedimentary rocks, right? And we're not going to talk specifically about the organic sedimentary rocks. There's really only one of them. There's a section in your textbook on coal that you should be reading. So that leaves us with the chemical sedimentary rocks, and we break them down into two groups. One group is inorganic. So this is a group that forms just when minerals that are dissolved in water precipitate out of water. So this is direct precipitation from water. The other group are called biogenic. They're sometimes called organic as well. This is when an animal makes a shell, and the shell becomes part of the rock. So when we named the detrital sedimentary rocks, we did it by looking at the size of the pieces, grain size. We looked at the composition of the pieces, sorting and rounding. We don't have any pieces with this kind of sediment, right? It just crystallizes out of water. So what we name the rocks through is their mineral composition. So when crystals precipitate out of water, we look at the mineral. We look at what mineral. So it's the mineral, whatever mineral it is that precipitated out of water, is what links to the rock name. So we're going to start with limestone. So limestone can form in both ways. Sometimes limestone forms from shells that were made by marine organisms. Sometimes it forms when the mineral precipitates directly out of the water. The composition is always calcite. So that's one of the minerals that we learned in the chapter 3. And we haven't talked about it for a while because it does not occur in the igneous rocks. But it's an important mineral for these chemical sedimentary rocks. So limestone is always made of calcite. When we talk about texture in these rocks, the rocks can be crystalline, right? That's what you get when you have crystals precipitate directly out of water. But the rocks can also be clastic. And the word clastic means broken. So if you have a rock made out of many broken pieces of shell, that would be a clastic texture. If you have a rock that's crystalline because minerals just precipitated crystals out of water, then that's crystalline. So again, limestone can be either. Biogenic rocks are more often clastic, right? Whereas inorganic rocks are more often crystalline. Most of the limestone that we see is actually made from shells that are made by marine organisms. So most of them are biogenic. Here are some varieties of limestone. This one is called coquina. It's definitely clastic. We can see all of the broken shell material that goes into making up this rock. They're just cemented together. This is the rock coral down here. This is basically the preserved structure of the little sort of buildings that little tiny coral organisms live in. So there would have been a little hole here. They've been filled in with minerals, and organisms lived in there, the coral. And then they created this structure, and it has been preserved and filled in with more calcite to make a rock. Over here we have chalk. Chalk is actually also made of lots of tiny, tiny, microscopically small shell material. And so you can't see it with the naked eye. You need a microscope to see these little tiny shells, but it is also biogenic because it's made of shell material. This limestone up here at the top is also biogenic and clastic. It's sometimes called fossiliferous limestone. You have lots of fossils in here, but they are actually cemented together by some calcite crystals that also precipitated directly out of water. So it's kind of a combination, but we still consider it biogenic because it has these big fossils in it. Then down here, finally, we have an inorganic limestone. So this is less common. This doesn't have any fossils or shells in it. It's just made from crystals of limestone, so it is crystalline, that precipitated out of water. Notice that most of these varieties of limestone are kind of gray in color. That's very common for limestone, a gray color. The next rock is dolostone, and dolostone is very similar to limestone. The rock that we have here in Rockford is mostly dolostone. It's mixed with some limestone, but people just tend to refer to it as limestone. Dolostone has a slightly different composition. Instead of calcite, it's dolomite. But if you look at the formula for dolomite, it's almost the same as calcite. So if we write the formula for calcite down here, the only thing that's different is that we leave out the magnesium, right? So the only thing different between dolomite and calcite is that there is magnesium in dolomite. And we call the rock dolostone, right? Same beginning. Texture is crystalline rather than biogenic, and this has to do with how it forms. So dolostone forms after limestone has already formed. So it kind of forms from limestone. What happens is groundwater travels through the limestone. So the limestone has already been formed. Groundwater moves through the limestone, and it's magnesium-rich groundwater, so it has a lot of magnesium in it. And that magnesium then gets deposited. So this water sort of replaces some of the calcium with magnesium. So because that happens, we don't consider this a biogenic rock. The previous limestone might have been biogenic and might have had shells. But when you get the groundwater moving through the limestone and you have this replacement, it recrystallizes everything. And so you get, instead of crystals of calcite, you have crystals of dolomite. And because of that, we sort of remove that biogenic texture. We'll see in a photograph later that often when you do see things like fossils in dolostone, they almost look sort of like a mold or like a shadow of themselves because they've been, all the crystals that made them up have been replaced, and it kind of dulls the edges a bit. So here are 3 photographs of dolostone. In this bottom one, you can see what I'm talking about with the shell. So we have basically a fossil here, probably a mold, but it almost looks like it's been slightly erased, and that's because of that replacement. But the important thing I want you to notice from these pictures is the yellow color. Now sometimes it's more bright yellow, like this one. Sometimes it's a duller tan yellow. But that yellow comes from the magnesium. And that's very distinctive for dolostone, and it's an easy way to tell the two apart. Limestone always looks more white to gray, and dolostone has this yellowish tint to it because of that magnesium that's been added. Okay, moving on, we have a group of rocks called evaporites, and they're called that because the rocks form when water evaporates. We're just going to learn two of them. There are more than these two, but these are the two most common, rock salt and rock gypsum. So they're forming when when crystals precipitate from water. So these are going to be crystalline. There are no organisms or shells involved here. That also means that they are going to be inorganic, right? Inorganic and crystalline. Composition is going to depend on the rock. So again, we base the rock name on what is precipitating. So if halite is the mineral that's precipitating, you remember halite is the name of salt, a mineral name for salt, then we make the rock salt. And you can't just call it salt or halite. You have to put the word rock in front of it because otherwise it's not the name of the rock. If gypsum, the mineral, is precipitating, then we end up with rock gypsum. And same thing, you need the word rock in there. Rock salt and rock gypsum will not be exactly pure, right? They're not going to be a single crystal or even multiple crystals of just that pure mineral because they're growing in a wet environment at the surface of the earth. There are going to be some impurities in there. So we distinguish between the mineral and the rock by using that term rock in front of the name. Both of the two that we're talking about come when seawater evaporates, which is why they are inorganic. This is a photo of rock salt. Sometimes students confuse it with quartz. It has kind of that grayish translucent look, but it's much softer than quartz. Halite is a much softer mineral, so you can break off pieces pretty easily with your fingernails and certainly with anything a little harder than that. It's also very salty, so if you like rub your fingers on it and then lick your fingers, you will actually be able to taste the salt. And this is rock gypsum. Rock gypsum, as you can see from the photographs, can look different in different varieties. One thing, though, that is generally true is that it's pretty opaque. Opaque means we can't have light shine through it. So it's not translucent like the rock salt was. So this opaque look, to me, always makes the samples look a little bit milky. It doesn't really matter what color they are, whether they're white or pink or orange, and all of those colors are possible. They have this kind of milky white pink or milky white orange kind of look to them. Now remember, gypsum was an incredibly soft mineral. You could scratch it with your fingernail. The rocks are not going to be quite that soft because they have those impurities in them. So it's still a soft rock, but not quite as soft as the mineral, the pure mineral. Then we have chert. The rock chert is always made of quartz. Its texture is microcrystalline. And this means that the crystals that make up the chert, the crystals of quartz, you would need a good microscope to see them. They're very small. There are names of different varieties because if you remember, quartz in its pure form is either clear or white, but very small trace elements of just tiny bits of other elements can change its color. So quartz came in many colors. Remember, a little bit of magnesium can make it purple. It can be yellow. It can be gray. It can be black. Just depends on those trace elements in it. So because of that, we have variety names. So these are called varietals. Flint is one you've probably heard of. It's a dark gray chert. Jasper comes in red and green. So the two varieties that are red and green are called jasper. and agate is when it is a striped kind of striped colors. So again, it's made of quartz always. Chert is always made of quartz. And by the way, these variety names are not the names of the rock, right? The rock name is chert. So when you discuss the rock, you're talking about chert. The origin is when silica, which is quartz, precipitates out of water, and it can be both seawater and also it can be water around hot springs. A lot of times that hot water will have dissolved quartz underground, and when it makes it up to the surface and cools down, a lot of that quartz comes out of solution and precipitates. You can see some of that in this particular photograph, this petrified wood over here. So this is a log that was basically sitting someplace near a hot spring, and slowly, as the water traveled through the wood was replaced by the mineral quartz. So we've got flint here, the gray kind. We've got the agate with the stripes. We've got some red jasper here. And then if quartz doesn't have any of those additional elements in it to change its color, it would just be this white chert. The mineral quartz is very hard, right? It's harder than glass. For that reason, it was made into cutting tools. So chert, the rock, is often found as arrowheads or other hand tools. Also, another thing you might remember about the mineral quartz is it didn't have any cleavage, but it did break with conchoidal fracture, and that was that kind of scooped out shape, and that helps to make the edges very sharp. So when you have that, and you can see that scooped out shape here, this edge is going to be much thinner than this edge of that cut, and that makes very sharp edges all along the sides. So it was used as primitive tools to help cut things. This figure from your book I just want to finish up with is showing all of the rocks that we've talked about, right? So here we have the detrital sedimentary rocks, and here we have chemical and organic, although for what I did, I said that organic is part of chemical. So this figure shows the grain size, right? So we have rounded particles in gravel size is conglomerate. Angular particles in gravel size is breccia. Then we have the medium. This was the sand size. So we have sand here. Remember, they have sandstone. We have two sandstones, the quartz sandstone and the Arco sandstone. And then we have the fine sizes with the mud, siltstone, shale, or mudstone. So then over here on the chemical and organic sedimentary rocks, the first thing we have is the composition. So over here we have the texture because that was what we used to classify the rocks. But for chemical sedimentary rocks, we use the composition. The first column is calcite. So all of these rocks are made of the mineral calcite, and that makes them all a form of limestone. So they've got crystalline limestone, travertine, coquina, fossiliferous limestone, chalk. We talked about all of those. As far as I'm concerned, you can just call them limestone. You don't have to remember the differences between the different types of textures you get with these different limestones. The only thing you do have to remember is that if you can see shells in it, it's biogenic, or what they call biochemical. If you don't see shells, it's crystalline and inorganic. Then we have quartz, which was the chert, gypsum, which was the rock gypsum, halite, which is rock salt, and coal is the one that we didn't talk about here, but that you should read about. It's made of plant material that has been compressed.